Hello, Coach Holmes here, and today we're going to be talking about transversals, okay? So we have transversal lines along with it. So what is a transversal exactly? Well, it's pretty simple. A line that intersects two or more lines at different points. Okay, so initially what we're looking at is basically this line right here. Let's go and call this L. This line L is a transversal line because it's crossing more than two lines through it. Okay, it's going through more than two lines. That's what makes it transversal. It's traveling through two lines. Now, so if you notice, So if you notice, we have two lines here, and because of this transversal, we have 8 different pairs of angles. Now, there's 4 different types of pair of angles that most of geometry deals with. We have alternate interior angles, alternate exterior angles, consecutive interior angles, and corresponding angles. Okay? So let's look at alternate interior angles. What alternate interior angles are a pair of angles where not only are they alternate from each other or alternate from the transversal, but they're also inside. Okay? So for example, just to give you an idea, 3 and 5, they're inside the two lines. 4 and 6 are inside the two lines as well. What happens not to be inside? 1 and 2, 3, 7 and 8. They're both outside, so they'll be considered exterior. So definitely angles 1, 2, 7, and 8 will not be alternate interior. However, the pair for angle 5 would be angle 4, because not only are they both inside, but they alternate. They're on opposite sides of the transversal. That's the big key for alternate. Alternate means they're opposite from each side of the transversal. However, that's not the only pair though. Another pair we have is angle 3 and angle 6, because these two are alternate from each other. So if I can just color code it like this, obviously they're not on the same side. I'm just trying to show y'all that they're alternate interiors. Trying to show y'all the pairs. Now, alternate exterior is the same idea, except I'm looking at the outside angles. So, for example, alternate exterior. I know my outside angles are going to be 1 and 2, 7 and 8. But what's alternating? From 1 alternates angle 8. What alternates 2 is angle 7. So you just got to remember that alternate is just opposite from the transversal. Now, consecutive interior angles is pretty unique, because not only are we looking for angles inside, but we're looking for back-to-back. So for example, 3 and 5, while they're both inside, they're consecutive to each other. They're back-to-back from each other. So angle 3 and angle 5 are consecutive interior angles. Angle 4 and 6, they're consecutive as well. They're back-to-back. So just remember, with consecutive, they're back-to-back or pretty much right next to each other. Corresponding. This is where you're looking at a general position from each line. So for example, the top left angle from this line, I'm going to call this M, is angle 1. And the top left from angle N is angle 5. So those two, angle 1 and angle 5, are corresponding angles. Now I want you to think about what will be the bottom left for both line M and line N. The bottom left is going to be angle 3 and angle 7. Top right from both M and N is angle 2 and angle 6. And bottom right will be angle 4 and angle 8. Now, we'll dig more into transversals and what these have to relate to each other when it comes to parallel lines and transversals. But again, that's for another day. But you should be able to identify alternate exteriors and alternate interiors, consecutive interiors, and corresponding angles. Just remember, alternate interiors are opposite of the transversal, while inside, alternate exterior are opposite from the transversal, but they are outside. Consecutive are right next to each other, but they're interior, so that makes it inside. And corresponding are the same general position. So if this angle on the top left, you're looking for the angle on the top left on the bottom one. So same general position. Now we have two different postulates. On the top on this row, the second row, we're going to have the definitions for each postulate, and the bottom picture is going to have a picture of it. The bottom row will have a picture of it. So let's talk about parallel, which is abbreviated as PAR. Parallel postulate. If angle A plus angle B equals to 180 degrees, then line L and line M are parallel. So what does that mean exactly? Well, imagine if I have two lines here. I'm going to call this L, I'm going to call this M. And I have a transversal line through here. Imagine this being angle 1, and this is being angle 2. If the total angle, if the sum of angle 1 and angle 2 add up to 180, then both of these lines are parallel to each other. Okay? These two lines are only parallel to each other if angle 1 and angle 2 adds up to 180 degrees. That is the only time that line L and line M are parallel to each other. Now, let's talk about perpendicular postulates. Only one line through point P is perpendicular to line D. So again, imagine if I have this line D right here. And I have point P. Now, there is only one line, and I mean one line only, that if I draw through point P, and I want to draw it in red, that makes it perpendicular. Only one line through P can be perpendicular to line D. Okay? And that's what gives us perpendicular postulate. So, what we just talked about is transversals, as far as a line that goes through not only multiple points or multiple lines, but also how do some of the angles in these transversals relate to each other. Thank you and have a good day.